Good morning, colleagues. Or good morning or afternoon, depending on where you are in the world. My name is Good morning, colleagues.
Morning, Level.
Morning, President. I'm sorry, I just had to mute because I'm also we're also live streaming on YouTube, so I think I was getting feedback from that. I'd love to welcome you to the very first session of the 2026 Data Analytics course. This is a collaborative course that we are hosting collaboratively with institutions around the BRICS countries. And today we have the pleasure of having Professor Feng, who is from China, but maybe just to give you a brief background on Professor Feng, I'm going to read his bio just quickly and then hand over to Professor Feng, and then we'll have a quick question and answer after Professor Feng's or Professor Wang's presentation. So if you have questions during the session, please feel free to maybe post them in the chat, and then we can get to them after his presentation, right? So Professor Wang is a distinguished professor in Guangzhou University, and he's a leading researcher in radio interferometry, imaging, as well as astronomical data processing, with a strong focus on scalable algorithms for the next generation radio telescopes. He previously served as an imaging and calibration specialist at the SK Observatory, where he contributed to key developments in calibration, imaging methodologies. He's currently a principal engineer in the the Square Kilometer Array Science Data Processor, the SDP, development team. He's playing an important role in the design and implementation of the large-scale data processing systems. In addition, he serves as a member of the advisory committee on the SRC Net, supporting the development of the SK Regional Center Network. Professor Wang has extensive experience among major astronomical facilities, including LAMOST, MUSA, and MUSER, NVST, as well as ONSET, and has led multiple national level research projects. His work addresses fundamental challenges in high performance and data intensive astronomy. So it's a pleasure to have Professor Wang with us. Professor Wang, over to you.
Okay, thank you very much. Let me share my screen. So can you see my screen now?
Yes, Prof, we can see your screen.
Okay, thank you. Okay, thank you very much. Thank you very much for this very kind introduction. And good morning and good afternoon, everyone. And welcome to the first week of BRICS Astronomy Data Analytic and AI Training Program. Today is my honor to be the first lecturer here. I want to start from astronomy, not from computer science. The reason is quite simple. Yeah, we do not learn Python because Python itself is a goal. We learn Python because modern astronomy now produces data in a form and at a scale that cannot be handled only by looking, clicking, and manually copying numbers. In this first tour, I will explain why programming has become a basic skill for astronomers, especially in the current AI era. Then, in the second hour, we will open Jupyter notebooks and make these ideas concrete. You will see variables, lists, strings, loops, functions, and files. Yeah, this may sound like programming vocabulary, but I want you to hear them as a scientific vocabulary. Yeah. They are tools for describing data and analysis clearly enough that a computer, another scientist, and your future self can reproduce what you did. Okay, so one important messages for today is that AI does not remove the need to learn program. It changes how we write code, but it does not remove our responsibility to understand the data, the assumptions, and the result. useful opening sentences is, I think, by the end of today, I do not expect you to be a Python expert, but I do expect you to understand why Python belongs in an astronomy in an astronomy classroom. This set a realistic expectations and lowers anxiety for beginners. So no worries. Yeah, I think Python is quite simple. Yeah, this is the structure of our next 2 hours. The first hour is a conceptual map, and we will begin with the astronomy context, current hot topics, bricks facilities, and the kinds of the data they produce. Then we will move to the data problem. Why images, spectra, catalogs, time series, and simulations force us to use computational methods. After that, I will briefly discuss AI and vibe coding. This is important because many students now ask, very reasonably, if AI can write programming legacy more valuable. Yeah, if AI can write codes, why should we learn programming? It is necessary for us to learn it? Yeah, my answer is that AI makes programming literally more valuable. But if you understood code, AI become a useful assistant. If you do not understand the codes, AI can very quickly produce something that looks convincing. Yeah, but answers the wrong scientific question. I do think you have met such situation. You ask lots of questions and you got lots of answers, but finally you are found everything is wrong. Okay, those the second hour is practical. We will open the week 1 Jupyter notebooks. I do not expect you to memorize every commands today, but I just hope you can learn how to read a notebook, run a cell, change a value, inspect output, and understand error messages. This is the beginning of real computational astronomy. Okay, let's first look at the science. I believe that lots of students here, maybe all the colleagues, are scientists. Yeah, actually, uh, many of the most exciting topics in astronomy today are also data challenges. Time domain astronomy is a good example. When surveys repeatedly observe the sky, they generate alerts for supernova, variable stars, asteroids, tidal disruption events, and many other phenomena. The scientific question may be physical, but the first practical problem is computational. How do we filter, classify, and prioritize so many events? Yeah, exoplanet studies are another example. A planet may reveal itself through a tiny dip in a light curve, a radial velocity signal, and or atmospheric absorption features. Cosmology uses enormous galaxy catalogs. Yeah, weak lensing, measurement, and simulations. Radio astronomy, this is my favorite topics. Deals with the interferometric data, pulsar, fast radio bursts, and spectral line cubes. Solar physics has high cadence imaging and space weather monitoring. So the common pattern is modern astronomy asks physical questions through complex data. Programming is the tool that lets us translate a scientific question into a sequence of reproducible operations on the data. Yeah, a good translation is to ask, why do all these hot topics have in common? Yeah, if you can answer from your mentally, you will see, yes, they all require us to move from physical intuition to structured data operations. I think this is the bridge to programming. Actually, this program is held by bricks. And we all know that Briggs astronomy is special interesting because it is broad, multi-wavelength, and international. We should not think of Briggs astronomy as one telescope or one narrow field. It includes optical and infrared observations, radio astronomy, space mission, theory and simulation, data archives, and training programs. This side, yeah, you can see that given a few examples of major Briggs related facility that data and data production products, it is not meant to be completed. It is a representative sample to help us see the connection between facilities and computation. For China, we can think of FAST, yeah, one of the world's most important single-dish radio telescope. You can see, yeah, this is just like a big pot. Yeah, these produce radio signals, spectra, catalog, and survey data. India has AstroSat, yeah, and maybe my pronunciation is not very good. Entity L1 and GMRT we know, and UGMRT, leading to multi-wavelength archives, solar observations, and radio interferometric data. South Africa has Meerkat and SALT, connecting to radio imaging, optical spectroscopy, and transistor follows-up. Brazil, Russia, and other BRICS partners bring additional observations, archives, simulations, and monitoring network. Notice, yeah, how different these facilities are. A radio telescope, an optical spectroscopy, spectrograph, a solar space mission, and a simulation code do not produce identical data. But for us, if we want to make some analysis, select objects, measure some quantities, visualize results, and communicate with the problem, communicate it with the methods. And we need to build some workflow which we can use in the future. Maybe we should have some studies on our based on our results and data from our facility. That means we have to use some special method. Yeah, that is the programming, and we must use computer to deal with lots of, or we can say this is a massive data from the facility. Okay, a useful way to think about a modern facility is that they do not simply produce beautiful pictures. They produce streams of data products. A telescope may create new exposures. Survey may repeat this process every night and every observing cycle. Yeah, this challenges the role of the astronomer. In old example, a scientist might inspect a small number of images or spectra by hand. Can you imagine that? Yeah, this still happen, and human judgment is still important. But at large scale, the first layer of work is usually a pipeline. And I think you know this word, pipeline. The pipeline calibrates, detects, measures, filters, and stores. Then the scientists ask questions through the pipeline outputs. This is why programming is not an optional extra. If the data arrives at table, arrays, files, and streams, then our scientific reasoning must also be able to operate on tables, arrays, files, and streams. Programming gives us the ability to repeat the same analysis consistently, to scale from one object to thousands, and to document exactly what was done. A helpful phase is a telescope gives us photons, but science comes from a chain of decisions. Calibration, detection, selection, plotting, and interpretation are all decisions. Programming makes those decisions visible and repeatable. Okay, yeah, we can talk about the challenge. The challenge is not only that this is more data. Volume matters, but complexity is just as important. Astronomical data are heterogeneous, and we combine image, spectra, catalogs, time series, and simulations. They are noisy. Yeah, you can see we have calibration errors, bad pixels, cosmic rays, artifacts, missing values, and the selection effect. They are high dimensionals. A single object may have many measured quantities, and those quantities may be correlated, right? They are time dependent. The sky changes, instrument change, and the observation have timestamp, cadence, and sometimes urgent alerts. This complexity is where many scientific mistakes can enter. For example, mixing units. Using the wrong coordinate system, ignore missing values, or applying a selection cut incorrectly can change the result. These are now, these are not just a coding mistake. Yeah, they become astronomy mistakes. So programming helps us because it forces us to make the steps explicit. Yeah, what file did we read? What rows did we keep? What units did we cover or convert? And what threshold did we use? Yeah, a good program is a record of a scientific decision process. We should understand that a good program is a record of a scientific decision progress. This is quite important for our future work. Okay, so we can see that during the latest maybe 2 decades, the word astroinformatics, yeah, is useful here. It means that the intersection of astronomy, data science, databases, statistics, visualization, machine learning, and computational infrastructure. It does not replace astronomy. On the contrary, the astronomy is becoming more powerful, yeah, than usual. It supports astronomy in a world where the data are too large and too complex to handle informally. So we should understand why virtual observatories is coming. Virtual observatories, yeah, archives, catalog service, databases, and the pipeline are all part of astroinformatics. When we query a catalog, cross-matching sources, download a phase file, plot a color magnitude diagram, or classify a transit, we are already participating in this ecosystem. So I think we have to introduce Python. Python is one of the practical language as in astroinformatics. It connects every naturally to notebooks, data tables, arrays, plots, and astronomy-specific packages such as AstroPy. This is why we start here. We are not trying to turn everyone into a software engineer, yeah, in 1 week. We are giving you enough programming vocabulary to interact with astronomical data system intelligently and reproductively. Later, yeah, when you use more advanced tools, this foundation will help you to understand what those tools are doing. Okay, so let's talk about something about artificial intelligence. Yeah, in astronomy, actually AI and machine learning are no longer exotic and marginal. They are widely used in large surveys, image classification, photometric redshift estimation, transit filtering, simulation acceleration, anomaly detection, and many other tasks. If you read the paper, yeah, from arXiv, from that something from the Harvard, you will find that there are lots of papers concerning about AI. Yeah, the literature has grown rapidly because the data demand it. Yeah, I think you know the Rubin. Yeah, the Rubin Observatory and the LSST era is a good example. When a survey produces enormous catalogs and alerts stream, automation is unavoidable. We need algorithms to pre-authorizing events, estimate properties, reject artifacts, and identify unusual objects. AI can help with many of these tasks. Yeah, but I want to be careful. AI is not magic. It depends on training data, assumption, validation, uncertainty estimations, and interpretation. An AI system may produce a label or a number, but the astronomer still has to ask whether the result is reliable, biased, physically meaningful, and appropriately for the scientific question. This is why programming literacy matters. If you understand the workflow, yeah, you can use AI critically instead of passing acceptance its output. If you simply acceptance the output of AI is quite dangerous because you will never know that the result is correct or not. Okay, so if you are excited with AI, actually all of us are excited with AI, but we must acknowledge that the wake of AI. Yeah, when we say that we can acknowledge that excitement of AI, we then immediately connect it to responsibility. An AI model is AI model in astronomy is only as good as data, labels, assumptions, and validation behind it. Programming help us examine those ingredients. I think this is quite important. Okay, so here are a few concrete examples of AI across the astronomic workflow. Yeah, galaxy. Yeah, we know the galaxy morphology classification is a classic example. Instead of asking humans to classify enormous numbers of galaxies by eye, machine learning models can learn visual features and apply them consistently at large scale. Yeah, photometric redshifts are another example. When spectroscopy is expensive or unavailable, models can use multi-band photometry to estimate redshift distribution. Yeah, you will see it's quite interesting. Yeah, in time domain field, time domain astronomy also relies heavily on classification and filtering. For example, distinguishing real astrophysical transit from the image subtraction artifacts. These examples show that why AI is attractive. It helps scale analysis. It can process many objects, identifying patterns, and support rapid decision-making. But each example also shows why scientific understanding is necessary. What labels was used for training? What objects are missing from the training set? How are uncertainties represented? What happens when the models see a rare object? So AI is just a part of the toolkit, but it sits on top of data processing, validation, and interpretation. These foundations are what we begin learning with Python. A nice way to end, yeah, we can see that these examples are not here to make Python look old-fashioned. They are here to show the AI itself depends on programming, data structure, testing, and reproducibility. reproducibility. This leads naturally to the viable code. I think everyone here, and we must know a new word, vibe coding. Yeah, you may have heard the term vibe coding, from internet, from your friends. In simple terms, it means using natural language prompts to ask an AI system to help write codes. For example, you might type, please write Python codes to read a CSV catalog and select objects brighter than magnitude ones. The AI may generate something useful very quickly, maybe in a few minutes. Yeah, this is a real change in how people write codes. It can help beginners get unstuck. Yeah, help experienced programs move faster, and help researchers explore unfamiliar libraries. But it is not a shortcut around understanding. The generated code may run and still be wrong. It may assume the wrong understanding. The generated code, may run and it may assume, the generated code may run and still be wrong, but it may assume the wrong column name in ignore units, I think, means handling, missing values, or use a selection rule that is not what you intended. So our attitude should be balanced. Use AI, ask it questions, let it help with syntax and debugging, but do not outsourcing the scientific responsibility. You must be able to read the codes. I think this is the primary goal of our training. You must understand, you must read, you must understand the codes you've written. You can test it on a small example and explain why the output answers your astronomical question. This is quite important for you. Okay, I think using AI is acceptable in learning. So maybe in the near future, you can use AI to write your codes. Of course, you can finish your homework, using AI, but don't forget, this is not a very good habit. And you must understand if you want to use it, a good AI assistant answer will be explainable by you. But if you want to do it, the first thing you must understand, and you should have ability to program. Okay. I think this is the central messages of our lecture in the week 1. AI changes the workflow, not the responsibility. We do not learn programming only because we expected to type every line of code by hand for the rest of our careers. This is not the point. We learn programming because it teaches us how to express scientific idea precisely. I want to repeat this word. We need to learn programming to express our scientific ideas precisely. When you write code, you are forced to specify the data, the variables, the operations, the selection criteria, and the output. That precision is valuable even if an AI assistant helps generate part of the syntax. In fact, the better you understand the programming, the better prompts you can write. And prompts is the entry of you when you're using your AI system. There are 3 responsibilities I want you to remember. First, understand what the data represents. First, do remember the first. Understand what the data represent. Second, verify whether the code is correct or whether the output makes sense. Third, communicates the method so others can reproduce and critique it. This responsibility remains with the scientist, not with the machine. Okay, so now we can define what's programming mean. Actually, yeah, a program. Yeah, I'm not sure that your background. Yeah, if you are familiar with computers, yeah, I think you can understand the program. Yeah, a program is a precise set of instructions that transforms input data into output results. In astronomy, the input might be a catalog, an image, a spectrum, a light curve, or a simulation output. The operations might include unit conversion, yeah, filtering, yeah, averaging, fitting, plotting, or classification. Control flow tells the computer when to repeat an operation, when to choose between alternatives, and when to stop. The output might be a number, a table, yeah, a table, not a desk, it's a data table, a figure, or a new file. This input operation control output structure appears everywhere. If you measure the brightness of a star in a image, yeah, you are transforming image data into a table of source properties. If you select exoplanet by radius and orbit period, you are transforming a catalog into a scientific sample. And yeah, if you plot a light curve just like this, you are transforming time and flux into a visual diagnostics. So programming is not separate from analysis. Programming is one way to make analysis explicit. Yeah. So if you have some background on programming, yeah, I do hope you can continue. And you should promote your ability in programming because this is quite important for your future work. Okay. So after the programming, and we need to talk about something about the algorithm. Before we write a Python program, we should talk about algorithms. Yeah, what's an algorithm? An algorithm is a recipe for solving a problem. It does not have to be written in a programming language at first. Yeah, a good algorithm can be explained in ordinary language. So no worries. Yeah, even if you cannot write by program by yourself, you can understand the algorithm because you can use your oral language, your native, your maybe the English, the Chinese, the ordinary language to describe one algorithms. For example, suppose that our question is which star in a catalog are bright? Yeah, it's very simple. Which star in a catalog are bright? Our possible algorithm is to open the table, open the catalog, right? And read each star's magnitude and keep the star with magnitude less than 1. Print the selected names, and then check whether the result makes sense. This is simple, but it already contains the important structure of the main scientific analysis. There are 2 lessons here. First, the algorithm is dependent of Python. Yeah, you could implement it the same idea in another language. Second, scientific algorithms should include checks. We do not only calculate, we also inspect, compare, and ask whether the result is plausible. Yeah, when we move to the Jupyter, maybe in the second hour, I want to think this way. What is the input? What is the steps? What is the output? And how do I check it? I think this is quite important for the beginner to learn programming. Okay, so here are some algorithms. Yeah, do not worry if you cannot write this code. Yeah, you will say, okay, yeah, I can understand now. No, I cannot. But no worries about that. The purpose of this site is just to recognize the piece. The first part creates a catalog. You see, is this a catalog? Yes, yes, it is. It's a simple catalog. Yeah. In real research, the catalog, would usually comes from a file or a database. But here we use a very small example. This is a real catalog. Then, you can see here, each star is represented by a dictionary with a name and a magnitude. Then the for loops, maybe we did not learn it yet. Yeah, the for. This for loop says repeat the following operation for each star in the catalog. Yeah, inside the loop. Yeah, the if statement applies the scientific selection rule. If the magnitude is less than 1, print the star's name. Yeah, you see, it's just like a natural language. Yeah, it's not very complex. Yeah, this tiny example already includes several week 1 concepts: variable, data structure, strings, loops, and conditions. You can see this is quite about 7 lines. Yeah, it includes lots of information, right? Yeah. So it also contains a scientific idea, sorry. Yeah, define a selection rule and apply it consistently. AI could help write this code, but you must understand what magnitude means. Yeah, did AI actually understand what's the meaning of magnitude? No. Yeah, it's just the probability. Yeah. So if you want to do it, you must understand the meaning of and the physical meaning of magnitude, right? So
Hi everyone. Okay, he's back. Okay. Prof, go ahead.
what's wrong? May I continue?
Oh yes, please. I think you dropped off just for a few seconds, but you please do continue.
Okay. I will hurry up. No worries. Okay. So why do we use Python in astronomy? Yeah. First, just I say the Python is readable.
Prof, I think you stopped sharing your screen.
Let me share again. Okay. It's okay now?
Yes, we can see it. Thank you.
Okay, thank you. Okay, just now I said the Python is readable. And the code often looks close to the scientific idea. This is the advantage of Python, which makes it easier for beginners to understand and to learn. Second, Python is interactive. In Jupyter Notebooks, we can run some small steps, inspect the output, change a parameter, and run again. This is quite simple and is very easy, so convenient to use. Yeah, the third, Python has a strong scientific ecosystems. Yeah, you may see that we have NumPy, Pandas, Matplotlib. Oh, sorry. We have lots of packages, yeah, in scientific ecosystem, the Matplotlib, AstroPy, and other things. Another important point in the AI era is that Python code is usually readable enough to inspect. If an AI assistant generates Python, yeah, you can often understand and test it line by line. This is very easy for you. This makes Python a good language for human AI collaboration. I think this is the goal of our training. You should understand how to write Python codes, and you should understand how the code works, and you should understand the codes generated by AI. Yeah. So maybe I will have a brief introduction for Jupyter, and we will use it in the second hour. Jupyter is the environment that we will use in the second hour. Think of it as a scientific lab notebook that can run codes. Yeah, you will see it. A notebook combines three things. Markdown. Yeah, Markdown cell contains text, explanations, equations, and notes. Code cell contains executable Python. Outputs show numbers, tables, plots, images, or even error messages. So yeah, we will have some experience on it. Okay. So I think this is a slide map that we're in of the week one. The topics may look like separate programming lessons, but they are really pieces of one language for describing analysis. Yeah, getting started is about the environment, how to open a notebook and run code. Variable give name to values. Data structure organize many values. Strings handle names, file names, labels, and text. Loops repeats an operation over many objects. Functions packages a repeated idea so we can reuse it. Yeah, of course, if you want to have some object-oriented programming, classes let us group data and method to get, and behavior, or we call say the method, into a custom objects. Files connect the notebooks to data outside the notebook. Yeah, modules let us use codes written by other scientists or other colleagues. Yeah, during the Jupyter hour, we will not treat this as abstract definition. We will connect them to small astronomical examples, star names, magnitudes, explore a planet, radii, optical period, and catalog files. Yeah, if you have today able to, if you live today able to read a simple notebook and explain what each piece is doing, I think this is already a very strong start. Okay, so first let me introduce variable. Variable are named for values. This sounds simple. Yeah, because everyone here, we should have a name. Yeah, but it's one of the most important ideas in programming. In the example, stars name, you can see that star name. Yeah, star name stores a string. Yeah, string. Yeah, you can see. Yeah, you can find that magnitude stores the number minus, 1.46. Spectral type stores the string A1V. Once we give these valuable names, we can reuse them. Yeah, print them, compare them, passing them to functions, and build some complex calculations. In astronomy, good variable names matter because they carry physical meaning. So I do hope if you are the beginner of the Python, you must find a way, have a good habit to set up your variable name. A variable name called X may be fine, but for a tiny example, but in real analysis, names like magnitude, orbital period, flux, wavelength, redshift help us understanding what the code is doing. Clear names may help when you return to your notebook. AI assistant can generate codes with variables, but they may choose names that are too generic or misleading. So do notice that. If you understand the variables, you can review the codes into something scientifically readable. Good code is not only code that runs. Do remember, it is code that communicates. Communicates with who? With people, with programmer. So the second concept we should understand is the data type. Yeah, data type tell Python what kind of value something is. Is in the example, magnitude is we call the floating point number. In brief, is float. Star name is a string. Yeah, and is bright is a Boolean value, either true or false. This matters because different types support different operations. If you want to program successfully, of course, you must learn and you must remember what type of data types we can use in Python. Yeah, for now, we must remember the following built-in data types is int, that means integer. Yeah, the float, that means floating point numbers. Complex, the complex number. Yeah, and bool, that means Boolean value. Yeah, in real astronomical data analysis, many problems begin with data types. A catalog column may look numeric, but be stored as text. Yeah, you will see that everything stored in text. So if you ignore that, you will read some different type of data. So missing values may appear as blanks, nan, not a number, nan, or special flags, dates and times. Yeah, may require careful handling. Yeah, if you want to process the data, such as data, date, and times. Yeah, be careful. So when code behaves strangely, one of the first questions is, what type is this value? Understanding types is a debugging skill and a scientific relay safety skill. Yeah, a practical demonstration we will have later. You can find how to read a value from a text file and then convert it into a number. Yeah, we will learn in the near future. Okay, the third concept we must learn is data structure. Actually, just we have learned it. Yeah, we just learned the data, the variable name, the data type. I think the data structure is the advantages and is a very important feature in Python language. Data structure let us organize many values. For example, a list. The first one, you can stars. Yeah, stars is a list. A list is useful for an ordered collection, such as several star names. Yeah, a tuple can store a fixed pair of values, such as right ascension and declination. A set, a set stores unique items. Set, such as the different spectral types that appears in the catalog. A dictionary, we just learned it. Yeah, a dictionary stores named fields, such as the name and the magnitude. For one star, we always call this is a key and a value. Yeah, actually, astronomy is full of structured data. A catalog is not just one number. It is many objects, each with many properties. A spectrum is a sequence of wavelengths and flux values, right? Yeah. A light curve is a sequence of time and brightness measurement. A simulation output may contain positions, velocities, masses, and many other quantities. Yeah, so choosing the right structure, I think it's the basic ability for us in programming. It will help us think clearly If every object has named properties, a dictionary may be natural. If older matters, yeah, a list may be useful. Later, we will use more powerful structure such as NumPy arrays, pandas data frames, and XtraPy tables. Yeah, but I think the course in the first week are the foundations, and we must familiar with all the data structures. Okay, strings. Yeah, strings and text values. Yeah, you can see that astronomy use them constantly. Yeah, object name are strings, right? You can see that the TRAPPIST-1e, the Kepler, yeah, 1865, and maybe other numbers. Yeah, seriously. Yeah, file names are strings. You can see that. Yeah. So catalog columns name are strings. Field names, observing logs, and yeah, coordinate labels. And the metadata always appears as strings. So in the example, we create a planet name and then build a file name by join text. Yeah, you can see here, we first set a planet, and second, we combine them together. It's called the join. And we also use a string method. You can see the lower, yeah, to convert the name into lowercase. These simple operations become very useful when managing many files or cleaning in constant catalog entries. Yeah, in real work, actually, string mistakes are common. A file name may have a capital letter in one place and not one another. A catalog may contain extra spaces. An object name may use a different conversion. A path may point to the wrong directory. These are not problems, yeah, but they can stop one analysis completely. Yeah, learning string operation makes you move effective at handling the practical side of data analysis. I think you should notice this. String is quite simple, but it's quite useful. Okay, so another concept, maybe we should have some statement. Yeah, in the first hour, we just see the concept of it. Maybe we can practice in the second hour and how to use them and how to do loops. What's the meaning of loops? You can see this is a loops, right? Yeah, loops. Loops allow us to repeat an operation without copying code. This is one of the moments when programming becomes obviously useful for astronomy. If you can analyze one planet, a loop lets you apply the same step to many planets. If you can process one file, a loop can process a dictionary of files. So if you can compute one measurement, a loop can help you to compute it for a whole catalog. Yeah. So in the example, the for loops goes through each planet in the list and prints a name in uppercase. You can see that we use for planet in planets. Planets is a list, is a data structure. So if there are so many planets stored in a list, and these two lines will print all the items in that list. Yeah, we will have a try. Yeah, when we use Jupyter. Yeah. However, yeah, we should know loops are also multiple mistakes. If the operation inside the loop is wrong, the wrong operation is repeatedly many times. So do remember, if you want to use loop, at first you must determine that your code is correct. Otherwise, you will make lots of mistakes. So check the first few objects and make sure that the loop is doing what you're thinking. In scientific programming, a loop is a tool for scale, but it also requires careful checking. Okay, conditioning. Yeah, this concept is very simple. Yeah, conditions allows the program to choose what to do. Yeah, we always need to have a decision on our life. We should select for turn left, and we should select to turn right. Uh, Yeah, so in astronomy, conditions often represent selection rules. If the magnitude is less than 1, yeah, call the object bright, right? If the orbital period is shorter than 10 days, select it as a short period planet. If the signal to noise ratio is too low, reject the measurement. Yeah, we should have to do it based on the conditions. This is where programming connects very directly to scientific judgment. A threshold is not just a programming detail. It defines your sample. If you change the threshold, you may change the population you study, the plot you make, and yeah, the conclusions you reach, right? So when you see an if statement, ask two questions. First, what does the code do technically? Second, what scientific decision does this represent? AI can write if statements easily, but it cannot automatically know whether your selection rule is scientifically appropriate. So that responsibility belongs to you, right? Conditions are small piece of code, but they often carry large scientific meaning. Okay, I think the last one we should introduce is the functions. Yeah, I checked the video last year, and the first hour should stop here. So let's uh, finish this function, this description. Function. Yeah, in general, we always said, yeah, if you want to use codes repeatedly, that I mean, if you want to use your codes repeatedly, and you must write a function. Actually, functions package is a reusable idea. In the example, you can see that we define a function. Yeah, the Earth's radius to km converts a radius measured in Earth's radius into kilometers. This function has a name, takes an input, performs an calculation, and returns an operator. Yeah, you see that radius is an argument we always see, or you can see this is a parameter. Yeah, this function has a name. Name means the Earth. The name is Earth's radius to km. Yeah, so functions are useful because scientific analysis often repeats the same step many times. If you write the same calculations in 5 different places, it is easy to make inconsistent changes. If you put the calculation in one function, you can test it once and reuse it. Functions make codes easier to read because the function name tells us the purpose of calculation. You may think it is very easy to write functions. Yes, of course. But the most important for us is that many scientists and colleagues, they wrote many functions, and we can use them directly. So in the future, if you still continuing to be researchers here, you should know a good function should usually do one clean things. It should have some meaningful input names and a meaningful output. When you use AI to generate codes, asking for a small function is often better than asking for a whole analysis pipeline. So don't ask AI, help me to write a paper on nature. No, never do that. But you can see, please help me to write a function, and I will use this function to do what. Yeah, blah, blah, blah. So, okay, yeah, the last concept, maybe we can stop here and we can skip to files. Yeah. So the last one I want to mention in the first hour is programming mistake. And this one should become a scientific mistakes. This is why we care about good habits from the beginning. A wrong type can make a number behavior like text. A wrong loop can skip rows and double count objects. A wrong file path can make you analyze yesterday's catalog while thinking you are analyzing today's data. Yeah, so these mistakes are normal. Yeah, we always say that you should have a life, but you must make the mistakes. Yeah, this is quite normal. Every programmer makes error every day. Yeah, the goal is not to become a person who never make mistakes. Don't believe that. The goal is to build a workflow that exposes mistakes earlier. Yeah, you can use print function and to output some preliminary or temporary results during your programming. Okay, so I think this is a learning loop. I hope you can practice in the Jupyter hour. And first, read the cell and do not run it immediately without looking. Yeah, it's quite easy. You just press your shift key and press your return key. You can run it, but this is not important. And you must ask what the code is supposed to do. Second, predict the output. This is quite important. This will train your thinking. Yeah, and even a rough prediction is useful. Third, run the cell. Fourth, okay, you see, change one thing. For example, you can change a number, you can change a string, or you can change a threshold, or list the element. Fifth, something breaks the code on purpose. Yeah, you know that errors are part of learning. Yeah, finally, explain what happened. I think this is quite important. So in the second hour, let's do it by following these 5 steps. Okay, so for the Jupyter hour, maybe we, actually, the goal of our Jupyter hour is not to complete every cell, and the goal is to learn how to use a notebook activity. But I think we can stop there. Okay, so I think we can stop here for the first hour. Any questions? Okay. Okay, the first one, maybe sorry for my pronunciation, is Anushka.
Yes, hello, Professor. Am I audible to you?
Yeah.
Right. So hello, everyone. My name is Anushka. I'm from India, and I'm a recent postgraduate student from UCL London. So my question is, you explained loops and functions. So I have two questions. The first is you mentioned when we use the loops, it can repeat the mistakes which are already in the loops. But then you also mentioned that we use the loops as well as the functions when we want to use some piece of code repeatedly, right? So then, like, what's the difference between using loops and functions? Because something that a function can do, a loop can do as well, right? So how do we decide which one to use when? Because both can make the same mistakes and both can perform the same action to repeat the code, right? So that is my first question. And my second question is you mentioned that loops can also multiply mistakes. So I want to ask you, can you give us some practical examples that are known to you when you realize that there was some mistake in the loop, which was getting repeated in the bigger picture, and that was later recognized, and that caused a little chaos, maybe, so we can avoid such mistakes. If you can give us some example of the mistakes. Thank you.
Yeah. Okay, thank you very much. It's a very good question. Okay, the first one, yeah, you can see on this slide. Yeah, you can see that if we want use loop to print all the items, all the element in a list. Yeah, currently we use planet.upper. That means we will is uppercase, right? So, but actually, if you only want to output the lowercase, you will see that all the answers should be wrong, right? So if you want to use loops, at first you must check the content in your loops. You must guarantee that this program is correct. Otherwise, for example, there are 100 planets, yeah, in this loop, and you will see, yeah, finally you will see that all the answers are wrong. That's what I mean. Yeah. So before you use loop to repeat it your work, you must first check that the work you have done. Yeah, you must check when the first one is correct, and you can continue. I think this is the first question. And the second question is a very good question. But may I have a demo for you during our second phase? Yeah, because it's very easy to demonstrate it, use Jupyter Hub with Jupyter notebooks. Yeah, currently I just have some PPT slide. It's not very easy to demo. It's okay?
Yeah, sure. I will look forward to it. Yes.
Okay,
Thank
thank you.
you.
Yeah, okay. So Harrison, please.
Hello, thank you, Professor. Can you hear me?
Yeah, yes, I can.
Yeah, so I just want to ask a question, just a quick one. From the PDF we downloaded, I could see that they gave us another option of using Google Colab. So my question is there any, is it mandatory to download the Anaconda or the Jupyter, since we can also do the same thing using Google Colab?
Yes, of course you can. Yeah, actually, we recommend you to use Colab on the google.com. Of course, we do recommend you can download Anaconda or maybe other software management to download and to install the Python system in your local machine. And you can use Jupyter Notebook or Jupyter Lab to run our program in your local server, yeah, your local notebook. Yeah, I think it's a good choice.
All right, thank you.
Yeah, Alabaji. If no questions, so shall we have a short break?
Yes, we can. And then we can move to the Jupyter Notebook sessions after that.
Okay. Okay, let's have a rest. Yeah, 5 minutes.
Perfect. I think we will call back everyone back at 10:12, I think.
Yeah,
10,
I
12.
hope they all have the link. So the Jupyter Notebook, the Colab one.
Not sure. We can send it in the chat. Maybe please send it in
Yeah,
the chat.
yeah. Well, that's just want to confirm again. I'll send it in the chat. Or do you have any changes, I think?
No, I use. Hi, Malabaji. Do you have some a countdown clock in your server or in your machine?
No. But I can call people back once we're done.
Okay.
Okay, done.
Okay, thank you very much. Let's just have a coffee break.
Oh, okay. Okay, I can do the time actually. Hi everyone. I think we can probably make our way back.
Yeah.
Perfect. Thank you so much, Prof, for the time, I guess, to have some tea quickly.
Okay. So should we wait 1 or 2 minutes?
Um, well, yes, we can, I think we can resume. I'm seeing that in the chat. I guess we have a lot of questions that we have to get to, I guess, once we're done.
Okay, let's go
Right.
ahead.
Perfect. Thank you so much, Prof. Oh,
Okay, so can you see this is my browser?
yes, I can see your browser.
Okay, it's fine. Okay, let's continue for the second phase. And yeah, I'm not sure that if you have installed your system, and yeah, I just checked the agenda. We can see that maybe in the first week or pre-course, and we should have some assignments that to allow you to install the system by yourself. So if you're not, okay, the first one is you can visit the GitHub, and you can find this URL in the chat of the Zoom. And if you cannot find it, just look it carefully. Maybe it's on the top of our chats. Okay, so don't use this way to download the codes. That in general, you can find the code here. Yeah, you can find that if you want to use git clone to clone this repository, and you can copy if you use HTTPS. Of course, if you use SSH, you can copy this link. Okay, so do remember, yeah, here we need to use the first one. We can select the HTTPS and just click here. You can find we copy URL to clipboard. Or the second, we have two methods, right? The first one is we can use Colab. Just have a quick check. It's Colab on Google. Yeah, if you don't have an environment in your notebook, in your local computer, no worries. It's very easy to follow our instruction. Okay. Oh, I'm very sorry. This is a Chinese characters, but no worries. Yeah. The first one is visit the collab.research.google.com. This is our collaboration. You can see here. Okay, visit. If you don't know the URL here, just visit Google. Yeah. So in Google, you can input collab Google. Yeah. You can find the first line. This is an entry of our collaboration. Okay, so second, you can find, at least you can find this GitHub. Yeah, right? So click GitHub and input the URL we just copied from here. Just now I introduced, you can visit the Courseware in the GitLab. You can copy this URL and just put it here and click or press enter. You can see that all the things you can see. Okay, this is the first, the second, 02, and 03. Okay, so I don't think we need to introduce it again. I think we can move to variables. Yeah. Okay, so if you can see this screen, it means you have connect to GitHub and copy one files, but don't forget to copy these files to your uh, hard disk in the cloud. Click here. Okay, this is the first way that we can we can use Colab in Google to check our courseware, to visit our Jupyter file. And then the second, if you want to have a try, you can download all the repositories. Yeah, here you can see here. Yeah, the second one is if you cannot use Git or you don't have Git, Git. Yeah, it's very easy. You can find, just click the codes. You can find a download zip. It means you can download all the zipped file that is the whole repository. All files are compressed, and you can download this compressed file into your local machine. And you can decompress them. You can find a directory. Yeah, you can use your Anaconda or other software to do it. Okay, for the beginners, I don't think you can install Anaconda by yourself in a very short time. And of course, if you have if you're interested on this, you can see, we can see Anaconda download. Yeah. If you do want to download Anaconda by yourself and install it and configure your environment by yourself, just try this. You can download Anaconda distribution by yourself. Maybe you will ask that we are learning Python. Why do you ask me to download Anaconda? It's very easy because Anaconda will install Python, Jupyter, and thousands of data science packages. Actually, Anaconda is just like a big file, including everything you need to learn Python. So if you want to learn it, just download Anaconda and install it. You have the full Python environment to do our further tasks. Okay. Yeah, so I'm not sure how many people here that who has installed your Python in your machine, or you can use Google Colab by yourself. Yeah, both way are very okay. Yeah, yeah. For example, in my mind, I have downloaded repository into one server. I use Jupyter, yeah, to connect to this one. Yeah, so I can use the full learning courseware in my local machine. Okay, so just now, and I found some colleague or friends said, yeah, we have lots of choices. For example, we have Jupyter, we have PyCharm, we have VS Code. We should understand that all tools are based on yourself. Actually, I'm familiar with VS Code because it's very simple and it's very small, and I can install all kinds of extensions inside the VS Code. Yeah, I found this very easy to use. But if you're a beginner for learning Python, I do recommend it you use Jupyter. I think this is the best utility tools I have ever used. Yeah, you can combine all the information together. I think it's quite important for the beginners. Okay, so no matter which tool you use, you can use, just now I said, you can see we can use Colab and we can use our local environment to open our Jupyter scripts. Everything is okay. So everyone here, so if you can run our scripts, can you press maybe 1 or 2, press a number in our chat, so I will know that how many people can follow of our work. So if you have installed all the necessary software and you can run our Jupyter scripts, it is possible for you to press or to input 1 or 2 in the Zoom's chat. So I can take a look. Okay, great. I found so many friends here, and yeah, you have installed. Yeah, quite good. Okay, let's continue. Okay, the first part I think we need to practice is how to set up a variable. Actually, just now we have said a variable, if you want to input some data or messages into your computer, you must name it. This is quite important. Yeah. So the first one is if you want to write a program, at first, the first concept you must understand is the concept of variable. Just now we said variable is a common terminology, right? So currently you can see this is the advantages of our Jupyter notebooks. You will see, for example, please click this twice. Yeah, you can see, okay, this is, what's the code here? What's the script here? It's called Markdown. Yeah, it's called Markdown. Yeah, it's a script language. And we can use Markdown to describe the text formats. For example, if we have some title, okay, in general, this is the first title. Yeah, the first class title. And this is the second class, the second level title, a caption, this is the third. So it's very easy to use Markdown. You can find lots of information on how to use it. Yeah, you can use to describe all the things you want to do, right? Okay, so you can see after you press and we can run it and it will change, convert it back to this formatted text. So the advantage of Jupyter Notebook is very useful and very interesting. You can combine your text, which means that your description, you have some text description for your scientific research. All the things you can write into the Markdown cell. Okay, so the second is you can see some cell. We call this code cell. Yeah, for example, this is the code cell. If you want to convert it into the Markdown cell, you just click this cell first, and then you can move your cursor and to click this one to change it to Markdown. Okay, so this one is Markdown. Of course, you can convert it back, draw it back. Yeah, this is code. So if you want to write your codes, do not use Markdown. Markdown cell is just for have some text on it, just for some description. You have some add some equation. You can find lots of website has some materials or documentations about the Markdown. You can learn it. It's very easy. Yeah. So okay. So if we want to understand the variable, okay, the variable name. The first one is what's a variable? Okay, so you can see the variable is a common terminology in programming for storing information. Okay, in Python, a variable is a symbolic name that references or points to an object. So once an object is assigned to a variable, you can refer it to the object by the variable name. Yeah, for example, if we want to add a cell here, okay, everyone, you can have a try. Just click this one and you will find some icons here. Yeah, it's very easy to understand. You can move your cursor and just hang in. You can find some not tips appeared. Yeah, for example, this one means insert a cell below, right? Okay, I click here. Okay, a new code cell is coming. Okay, so I can see my name. Okay, so this is one, the first. So if we set this one, this is a variable name. Of course, this one, we always say, we use this name to store a string. This string is, okay, the second one is, let's print my name. You can see, okay, so how to run it? You can see, if we click in this code cell, you can find an icon. It's just like an arrow. Yeah, run this cell and advance. You can find a shortcut header. It's Shift plus return. Yeah. So just click it. Yeah. It means okay. It output my name, and my name is displayed in the screen. Okay. So just now I introduced, if we want to design or assign a variable name, and we should have some rules. Do you remember what those rules are? For example, if you want to name a variable, what is the rules? Okay, so you can see here, the variable's name, we must follow some rules. The first one is variable name must be start with a letter or an underscore. Okay, so the second one is the remainder of the variable name can consist of letters, numbers, and underscores. And you can see the variable name are case sensitive. That means the star name and the star name are different variables. And you should see the variable name should be descriptive and meaningful. This is quite important. Yeah. Don't use a very simple abbreviation such as SN. Yeah, we always say this maybe is a serial number, right? Maybe we cannot understand it's a star name. So, and the last one is avoid using Python keywords and built-in functions. Yeah, you will see, oh, there are lots of functions, lots of named has been defined by Python. We do not use it at, we cannot use these variables name as a variable's name. So, okay, so this is the first one we need to understand. Okay, so it's very easy. I will have a question for you. Yeah, okay, you can see I will insert a new cell here. Okay. I just read the underscore equals 1. I ask you, is correct or not? So everyone here, if you think it's correct, just press input yes in the chat. If you find it's wrong, just press input wrong. Maybe you will say, I never seen it, right? Underscore equal 1, what's the meaning? But as we know, we just learned what's a variable name, how to define a variable name, and we have some rules. Yeah, yeah. It's so interesting. I found maybe half of the people here are wrong. Just now, let's go back to the rules of our variable. Okay, so you can see variable name must start with a letter or an underscore. So this is mean the underscore is a valid variable name, right? Of course, you can see maybe we need to write it like this, and you will see this one I can understand. Yeah. For example, if just now I say this is Earth radius. This is, you can see, of course, this one is a valid variable name. But don't forget that the underscore is a valid, because this can be the first letter, right? So if I say the Earth radius, okay, let's continue to say the Earth radius. Okay, I will run it. Okay, you can see that is no error. Yeah, so, but I will copy it, remove that Earth radius. I just leave only one underscore. You see, it's correct. So you must remember all the rules, especially in the beginning. Okay, so the second one is we always see 3x equals 5. So this is a second round of testing. Like, okay, let's have a test. Is it correct or wrong? You can continue to input your answer in the chat. Great. Yeah, it's very nice. Almost all people said it's wrong, right? Because just now we said that if we want to define a variable name, don't forget here, yeah, don't forget. Oh, sorry. Don't forget that the first one must start with a letter or an underscore. That means a number cannot start with. So if you want a variable just like here, the 3x, it's wrong. Okay, if you found it's wrong, you will see something special. Okay, you can see the syntax error, right? It said invalid decimal literal. So it means you have some errors in your codes. But no worries, if we just need to remove the first letter, cannot be the numeric. Okay, so okay, this is wrong. Okay, so if you want to learn Python by yourself, or you can learn from this course, don't forget to remember something, yeah, in some definitions and some descriptions in the Jupyter. It's quite important, and you must remember it. Okay, the second one, we just talk about the data type. Okay, the data type is very easy because in the reality, in the real life, we must store all kinds of data, all kinds of information, yeah, into the computer. So we have some at least 4 data types we need to remember. Do you remember that we just learned about 4 built-in types? Can you repeat it in the chat window? Yeah, the first one is without a point. Do you remember what it is? Integer, that's great. So yeah, the first one is int. Yeah, the second one is float. Great. Yeah. Okay, Nelly. Yeah, very, very good. We must understand that we have int, float. Yeah, the complex. Right. Yeah, actually, the first one, int, float, complexity are the numerical value, right? So if we want to store in general, yeah, we always save my age with an integer. We never say I'm 11 years. I will always say I'm 19, I'm 11, I'm 22 years old, right? We never say I'm 22.4 years old. That's right. So we can use an integer to store our age. But if we want to store something about our currency, about the money, yeah, in general, we always say we should use point, float point, new number to do it. This is float data type. So before you want to store something into your computer, you must have some concept. What data type will you use? Yeah, so it's very easy to understand. If you want to save some numbers without the point, they are all integers. You can use int. This is the first one, int. The second one is if you want to have some floating point. Yeah, we have the 219 point. Yeah, you can see. Yeah, 9021. That's right. So if you want to store the value like this, you must use floating point numbers. Okay, the third one, which is a common one, and we use it very much, yeah, is strings. Don't forget, this is called the string, str. Yeah, we always say int, float, and str means strings. Okay, we can have a test for the strings. Yeah, So if we want to store a string, you can see this is a variable name, and this is a value of this variable, right? But you will notice that if we want to save some text information into a variable, don't forget to use this signal here. Of course, you will see, can we use this? Of course, you can use that. Yeah. Right? It's correct. So it means you can use this one. It's a single quotes and a double quotes. Yeah, that's right. Both are correct. But you will see my name is okay. So sometimes we see, yeah, whose book is this? That's right. Whose book is this? Or can see whose book? Whose book is this? Yeah, you will see that we use double quotes to that's this single quotes is included in this string, and this one is correct. But don't use this. If you try using this one to define a string, it will be wrong. It's very easy to understand because computer will regard this pair as one. So you will find you have additional single quotes. That's right. So of course this is wrong. Maybe you will ask, so if we use this one, is correct or not? Okay, everyone, can you have a try? Can you give me an answer? It's correct or not? Really? Okay, so strings are representation of characters. So you must just have strings are be enclosed in single quotes or double quotes. That's right. So if you use the single quotes as the outside, okay, this one is correct. I will run it. You can see it's correct. Of course, from English, it's wrong. That's right. But from computer language, it's correct. So don't forget, you must have a pair of single quotes or a pair of double quotes. Yeah, be noticed. Okay, so this is second. And sometimes you have a very long, very long text want to store. How can you do it? Okay, let me have a demo. I will click here. For example, I will say, this is my first day to learn Python. I love Python very much. Okay, if we want to store this text into a variable, we can see this is a message equal. Okay, we can use this. Maybe, okay, so I will say print message. Okay, I have shown this command. This is a function. We use print function to display something on your screen. Okay, so you will see here, okay, it says, okay, it's wrong. You may misunderstand what's wrong with it. Okay, so let's join them together. Is this correct? Let me have a try. Okay, you found. Okay, it's correct, right? Yeah, this is a very long string, but we use a pair of single quotes to combine them together. Okay, so this is correct. But you see, sir, I don't want to display like this. Yeah, I don't want to like it. How can you do it? So in this time, just use 3. Yeah, this is not a single, not double. It's just the triple quotes. You can see here. Okay, you are found. So if you want to use you can use the triple quotes for multi-line strings. Okay, so I think Yeah, it's very easy to understand. So you can write just a letter. Yeah, it's very long, no problem. Okay, so the first one is int. The second one is float. The third is string. Yeah. The last one we should understand is Boolean. Yeah, will the class be posited on YouTube today? Maybe not. Maybe in the second course. Yeah. Maybe in the afternoon. You will learn it. But maybe in my course, I don't think we have time to do that. Okay. So let's continue. The third one you must remember is Boolean. Is just like yes or no. Yeah, that's right. So Booleans represents one of two values, but we must remember the first character should be uppercase. Yeah, this is a uppercase T and F. So do remember, don't use other styles. For example, you can see this is galaxy is true. You will find the color of true is green. Yeah, but if you see like this, you will find, okay, it's not true. It's correct. So do remember, if you want to use Boolean, you must check this is true. And do remember the first letter. The first letter should be uppercase. Okay, so the second one, if we can remember that there are four data types, and the second that we should learn and should remember is the data structure. Actually, use data structure is not very difficult, but maybe in the beginning, it will be little. For example, you can see here, we have some dictionary. Yeah, this is a syntax of dictionary. You will see the name, the alphabet central. Yeah, in this, yeah, you can see we have 4 lines here, and in each line, the first one we call the key. The second is called the value. So if we define a dictionary with 4 elements, we can output the value just like this. For example, we can see feature, attributes, bmag. Oh, sorry. Okay, so this means we can use bmap to look it up from the dictionary. Okay, so we use bmap to take this value out. It's just look it up. Okay, right? It's a dictionary. Okay, the following concept we can understand. I don't think it's very useful, but because sometimes we output lots of data, and we should define some format of our documentations or text file. So maybe at that time we should use escape characters sometimes. So actually, for my point, I don't think you should remember lots of information on it. You can just remember this one. And this one, I think is enough. This one means the escape character. Escape character. You can see if I remove this one, for example, you can see this is a string, right? Yeah, it's very easy. They are all in the one line. But if you want to have a return here, you want to divide it into into 2 lines. That escape next n, that means next line. Yeah, so if we use this method, we can insert a new line in a string. So do remember is this one. And another common escape character is table T. Actually, it's just like insert a table. You can see that there is a key in your keyboard. It's a table key. It's just like the output of just like you press your table key. So I don't think it's quite useful, but do remember this one, you will use it when you want to output a very large text file, and you should insert a new line and convert it and add a new line. Okay, the last one, we should have some introduction is the comments. Do remember that writing your codes is very important, but understand it, yeah, write your codes. Write your codes is your first step, but make your codes to be understandable by other people is more important. So if you want to make your program readable, you must have some method to comment it. Do remember, if you write a very long codes, add some comment in the place that you feel is important. For example, if you want to explain something, maybe it's very hard to understand, or you have a very complex equation, you can have a comment here to describe why you design like this, or why you write your codes. Yeah, it's quite important. Yeah, to make a line like a comment, just press a hash here. So if you have a hash there, that this line will not be executed by the Python. Yeah, Python will just read it and let it be. Okay. Yeah, so this is the first part of our variable. I do remember. Yeah, for now you have remembered the 4 types. Yeah, maybe one dictionary, and we have some special. The one is escape character, and another is comment. Yeah, it's quite easy. So the second one actually is very easy. It's operators. Operators are the special symbols. Actually, this is quite simple because we have learned it from when I was very young. That's right, in the elementary school, or maybe that as a pupil or a very young student, we have learned it. Yeah, it's addition, subtraction, multiplication, division, and the floor division. Maybe you don't know this. Yeah, and this modulus and exponent. Yeah, we will have a very simple examples to do that. Okay, I will insert here. If A equal 1, B equal 2, C equal A plus B. Of course, everyone here, you must know the value of C, is that right? It should be 3. So we use an operator here. It means addition. So if we have 3 here, and this is 7 here, okay, if I ask you what's the answer of it, it's not very easy to do it because it should be a float point, numeric, is that right? But you will find if we have such floor division, what's the meaning of that? Just read it. Divides and rounds down to the nearest whole number. Okay, everyone, can you give me an answer of this script? What's the result of this? Don't forget, rounds down. Rounds down to the nearest whole number. Whole number. That means it should be the integer, not. Yeah. Yeah, I found it's very interesting that in the beginning, lots of people select 1, but now lots of people select 0. So can you guess? Oh, obviously the 3, I don't think it's a good answer. Okay, let me show it. What's the result of it? It's 0. Why? It's very easy to understand. Yeah, you can see if we don't have a floor division, it's just a division. Of course, just now we said it's 0.57, right? But if we want to round down to the nearest whole number, that's right. So you must know it's rounds down. So rounds down means we will ignore all the numbers after the point. So the 0 is the correct answer. Right? Okay, so the second one is sometimes we will use it modules. That is means the returns the remainder of the division. Okay, so it's very easy to say. This time, let's see A equals 4 and B equals 7 and C equals B modulus A. So what's the value of C? Kamel, great. Well done. Yeah, right. Yeah, Aniska, great. Yeah, perfect. Yeah. So we always know if we divided 7 divided by 4, of course, the remainder should be 3. Yes, 3. Nice. Very nice. Okay, so if you want to, okay, the last one is exponent. Okay, it's very easy to understand. Yeah. A equals 3, B equals 2. We can see that A double star with B. Yeah, this is very easy to understand. This is should be 9 because it's 3 multiply 3, 3 times 3. Okay, so in the following, you can understand, yeah, the codes following. It's not very easy. It's not very difficult to understand. You can just read. Okay, for the first one, if we finally read this code, you can see the distance Earth Sun. Okay, it's a very good name of the variable because if we read this, of course, we can understand immediately what's the meaning of this variable. It will represents the distance between the Earth and the Sun, right? So this variable name is very good. Of course, it's maybe a little long. Yeah, but no worries. Yeah, of course, you are a native speaker. You can type very quickly. So don't name your variable name very shortly. You must make it meaningful. Yeah, so this one is very good. And you can see the distance Mars, Sun, and you can see this is the distance between the Mars and the Sun. Yeah, of course, if you found this value, you will see, okay, this is a float point number. That's right. So we see this, we just see the total distance between the Sun and the Mars and the Earth, and we can plus add these two values. Yeah, so we can, okay. So at this time, we found a new function, maybe a new feature of print. It's very easy. You can see that if we found this double quotes, we understand this is a what? A string, right? But before the string, we found a very strange f. Yeah, we called this f string. Maybe you are familiar it in the near future, but maybe this is the beginning. If you found a f in the beginning of the string, it's called f string. F string means you can change or you can output some formatted text. Yeah, we can see here. Let me run this cell. Okay, you will see here is total distance. Just now we understand this is a variable name. That's right. But in the final displayed text, you can see these values has been replaced. So it's just like a placeholder. Yeah, the value will be replaced automatically when you output this message. So you can see the total distance means the whole distance from the Earth to Jupiter and is 6.2 AU. Yeah. So we can use this method to output the formatted text as we wished. Yeah. Of course, if you need some more information, you can check other documentations. This is a very beginning course. So you can just understand, oh, this is a F string. If we need some more information, ask AI. Yeah, okay, you can see ChatGPT. Tell me something about F string in Python, right? Okay, so I think this is the best way we use AI. If you did not understand something or you forget something, you can ask AI to help you. Yeah, and AI will output some very useful information to show how to use it. And you can see that how to, if we want to use it, how can we define what's the standard syntax of this function? Yeah, in this case, we use fstring to output the name and the age. Yeah, so it's very easy, right? Okay. So after this one, I think we can finish the first part. And because, okay, sorry, I forgot. After that, the basic arithmetic operators, we have some comparison operators. This is the equal to, not equal to, greater than. I think everyone here, you actually you are very familiar with computer. So I do believe that you can understand it very easily. Yeah. So if we have these comparison operators, you can design some conditions, and it's not very easy to do that. Not very difficult to do that. For example, let's check this codes. Okay, we can check. We assigned 4 values to 4 variables, right? And here, this is our first time to meet such statement. We see the sun temp Kelvin equals 5,800. We can see this is a double. Do remember, this is not single. This is a double equator. So equal to. So what's the value of sun temp Kelvin? You can see here, we assigned the 5,778 to store in this variable named sun temp Kelvin. So of course, is this condition correct or not? Of course, it will not. Yeah, I think we maybe we need to re-enjoin. I need maybe I think maybe 20 minutes. I'm very sorry. Carmel, I'm very sorry.
No, that is fine, Prof. I think maybe we can maybe attend to questions in the meantime.
Okay, fine. Okay, so you will see this is of course is not, it's false, right? So here you can see we output the value using fstring, and you can see here, okay, this is false. Okay, so the following is very simple, and I think now you can understand how to use it and understand what's the meaning of that. It's very easy to understand the following scripts. So now, okay, before you run it, do remember you should understand. First, read the codes. Oh, okay, the second step, run your codes in your brain and try to understand what's the meaning of that, what will a computer to do, and finally, you can guess and you can expect your expectations. So, right? You should calculate it by yourself on your brain, in your brain. And you can try what's the final results of this script. Is it as the same as my result in my brain or not? If yes, that means you understand it. If not, that means maybe you have something misunderstandable, maybe you have something error or confused. Yeah, so after this training, finally, you can understand all the concepts. Okay, the second one is, let me hurry up. Okay, the second one is not very difficult to understand, but we only have one tuples and a list. Okay, let me first introduce a list. You can see lists are ordered. Mutable sequence, meaning you can change, add, or remove element after the list has been created. So we always use list to store many informations. Yeah, just now we introduced the variable. Yeah, at the first step, this is the first 02 variables in this Jupyter file. We define a variable. Yeah, that's right. We defined one variable and to store a single value. But if we want to save a lot of value, for examples, if we make an observation on a star and record the flux of the stars, it will generate a light curve. That's right. Yeah. So if we want to record the 30 values of the observation, how can we do? That means we can use list to store a sequence of values. So we always use list to store it. But you will see how can we do it? We can have a try. For example, I will add here. I will add a new. For example, at this moment, we can see the flux. For example, yeah, the number is of course is incorrect. Just a demo, an example. That means we can use one variable name to store lots of information, right? You will see we have 5 elements stored in a list. Yeah, but you will see, okay, yes, I want to take out one value, no worries. The first value is 0, the second is 1. Yeah, so if you want 4, that means we can take out the value just like this. Okay, so we see this is a list. The first value in the list, we call the index value. Index is 0. The second is 1. Okay, so it's very easy to deduce that if you want to get the 3, how can we use the code to do it? Okay, so okay, no worries. I think, yeah, okay, we can change the index into 2. That's right. Okay, Sandra, I think you can join the session too. No worries. I think you can. Okay, so this is very good. Yeah, it's very easy. That's right. You can understand how to retrieve a value from a list. Okay, so let's go back to the tuple. You will see, okay, what's the difference between tuple and a list? You can see, okay, I will add here flux equal. You will see, okay, I will see here, this is flux 4, 3, okay. You found it, okay, it's very strange, it's confused, it's the same, right? So you will feel confused. What's the difference between tuples and list? Just like me. Okay, let's take a look. What's the difference between the list and tuple? We see the list is changeable, but the tuple is unchangeable. For example, let's do it. And this time, let's just have a demo on how to use append. Okay, flux dot append. That means we want to add an item to the end of the list. Okay, currently the list name is flux. Okay, we want to append 6. Okay, let's print again. Okay, the first line is original flux, right? And the second is a new. But can we do this here? No. Let me have a demo very quickly. Okay, so the first one is tuple cannot support append. Okay, so we can see just now we said the flux2 equals 10 print flux. How? Okay, we will copy this file or these two scripts here, and you can understand what's the difference between them now. Let's do it. Okay, the first one, we initialize, we create a new list. We print the value of flux, and we change it flux2. Okay, guess who will be replaced? will be changed. Okay, this is 0, 1, this is the second, first, this is the second, right? So we can output 1 to 10 for 5, right? Okay, but let's go back. You will see the tuple objects do not support item assignment. So it's very easy to understand what's the difference between ituple and the list. Simply speaking, you can see that list can change the value. You can insert the values into list. But for tuples, yeah, it will be created initially. After that, you will never change it. So you will see in which occasion that we need to use tuple. I would like to say, if you want to save some parameters that were never changed in your programming, do remember to use tuple to store your parameters, because these parameters cannot be modified during your execution. So it will be very safe to do that. Okay, so so please learn it by yourself, and you will see the set. It's very easy. Set are unordered collection and unique. Okay, the advantage of set is unique. Yeah, I will say let's make a very simple. You will see some examples here, and yeah, you will understand that there are no duplicated elements in set. So if you want to use set, you must remember there are no duplicated values in a set. Oh, the last one is dictionary. It's very useful, and you must familiar it very much. Yeah, because in our programming, maybe every day you must use a dictionary to store informations. We always call this is a key value, KV, KV. This is a key. This is a value. We always use our key to retrieve the values from a dictionary. It's quite important, and you must learn it. Okay, so after you learn it by yourself, or maybe you have some fundamental concepts based on our teaching, and you must finish and try to finish these assignments by yourself. Yeah, if you can understand what's the meaning of that, I think it's not very difficult to do it. Maybe I still remember, I do believe that you can finish it within 10 minutes. Okay, the 4 strings. Actually, we have talked about something about string just now, and you can see how to create and manipulating strings, and how to concatenating strings, and use F string, and maybe we can have some method. Yeah, it's you can understand it after reviewing the codes. Yeah, just to remember, first read it and try to understand the function which has been used in this script, and guess what the result would be. And after that, run it and to judge your results. Okay, it will help you a lot to understand in the beginning. Okay, I think this is the last one I will introduce in the first phase. Okay, and just now I want to answer a question about okay, this time, what is a loop? I will create a new code cell here. For example, everyone here, if we want to plus 1 plus 2 plus 3 plus 5 plus until the 100, what the result would be? You may say, okay, this is a story of quite famous mathematicians, yeah, Gaussian, right? So if we see like this, we can see S equals 0. You will see what's the meaning of that? We assign 0 to S. And second, we have for I in range. Maybe you want to know what's the meaning of range. Okay. This one is a loop. That means we will print I. Okay, let's first run it. Yeah, you will find the value. The first value is 0. The last value is 100. So guess, if we set the range 100 and 1, right? It will output the 0 to 100. So it means we should loop total 101 times. So if we only want to loop 100 times, we can use a very simple code here. That means we will start from 1 and finished at 100, not 101. Okay, it's just like 0. Okay, the first one is less than. Okay, less than equal. Okay, great. Okay, send just less. Okay, so let's run this code again. Oh, sorry. Okay, at this time, we will find the value of I. Yeah, the first one is 1, and the second is 2, and the last one, you can see here, is 100, right? So let's put a very simple code here. S equal S plus I. Okay, so this time, let's print S here. You will see why S equal S plus here. Okay, finally, we will get a very important value. Yeah, 5050, right? This is a loop. Of course, you can see during this loop, what will a computer do? The first time, the first step, when I equals 1, at that time, S equals 0. So 0 plus 1 will be 1. So 1 will assign to S. So this time, S is 1. So at the second loop, I is 2, right? So S is 1. 1 plus 2. At the time, S equals 3. So in the third loop, I is 3. S is 3. 3 plus 3. At this time, CS equals 6. So in the for loop, yeah, I is 4. So 6 plus 4, S equals 10, right? So you can understand why the loop is so important. Because it will decrease lots of workload you have to do. Of course, if you want to write a very simple, you can like codes like this. 1 plus 2 plus 3 plus 4 plus 5 plus 6. Oh, it's so boring, is that right? But if you use loop, you will find that lots of workload has been decreased. But of course, if you have some errors here, you forgot this is just a plus. But you, for example, you just got multiply. What will be? So if you write loops, do remember you must guarantee that the codes inside the loop should be correct, right? If not, everything is correct. Everything is incorrect, right? So be careful to do that. Okay, I think maybe I would like to stop here because it's too long for you. I'm very sorry. Maybe in the beginning, I have tried to speak so quickly, but finally, maybe it's not very easy for a non-speaker. So, okay, let's have some questions and answers. Yeah, Harrison, please. Am I got wrong? Yeah, Harrison, your turn.
Yeah, thank you, Professor Feng. I want to ask a question. When you were discussing about variables for the assignment operation, the F string is not was not used while doing the assignment operation. If you should check back when you were explaining the variables for variables. So for the assignment operation, the F string was not used. I want to know why. And I think I don't know if if it's going to work. If let's say why because the use of the F string is for you to call a function in a string, right? So
Mhm.
I want to know if let's say you're after the string, you want to call the function, you call the function after the string, that is after the double quotes. If the script is going to run after the double quotes, I don't know if you understand my question.
Yeah, I think I understand. Yeah, thank you very much for your question. Actually, let me ask AI and you can understand now. Yeah, if you ask AI how many methods can Python deal with format output, you will see that lots of functions, lots of methods can be supported by Python. The first maybe the very familiar one currently is F-string. But for many programmers, maybe they don't like F-string. They will use string.format. Yeah, you can see, uh, can you see this one? It's a legacy method.
Yes, I
And
can
we
see
have
it.
about, yeah, it's a string template. So we have lots of methods to do it. Yeah, so if you are a beginner or maybe you are a master of this programming, actually you can select one, a favorite one as you likes.
All right. All right.
Any
Thank
method
you.
can be used to output formatted text. Okay,
All right. Thank you, sir.
okay, thank you very much. It's a very good question. Yeah, Aniska, thank you.
Hello, am I
Yeah,
audible?
yeah.
Right. I wanted to ask a question about the homework assignments. So on the ebook, for the week one, it shows only the setup of Collab and Anaconda and other things. And for the week two onwards, it shows the use of Python, and then for the week three, it shows the data structures and other things. And accordingly, there are assignment descriptions currently visible on the homework app platform. But in the Google Colab notebooks that we have been given, I think the content of the first 3 weeks, which is marked in the textbook, it's covered in the first Google Colab notebook. So the distribution of the modules between the textbook and the and the Colab notebooks is not the same. So I wanted to ask you about the assignments. So is it going to be like the Google Colab is going to cover the substances in advance, which are yet to be covered by textbook and by the homework assignments? Like, how is it going to be?
Uh, I think it's not very easy to answer it. Yeah, may I apologize? So can you answer this question?
Yes.
Yeah,
Yes, of course.
okay.
Yes, and thank you so much, Anika. So the assignments on the learning management platform would be updated on a weekly basis, right? So for this day, for today's what you call this, for today's assignment, this week's assignment, we wanted you to make sure that you have your setup ready, right? You know how to what you call this, start a Google Colab project, you know how to use a notebook, right? And at least submit something, right? But then the assignments would then be updated on a weekly basis. So what is on the platform now will change every week. So you'd have to then log into the platform every week to then see your assignments, right? So but they would reflect, your assignments would reflect what is on in the Google Colab as well as the GitHub, right? So please do stay on track with the GitHub itself, because that is what we would be using to set the weekly assignments, right? So remember, the weekly assignments are there to help you then make sure that you learn or understand what has been said in these lessons, right? And prepare you for the bigger capstone project at the end of the 10 weeks, right? So yeah, I hope that answers your question.
Yes, and I do have a follow-up question about the deadline for the submission of the homework assignments. Is it going to be on the Sunday evening of each week, and by which time zone?
So we are not too strict on the time zone, right? But we'd love that you submit your assignments before Sunday, right? Or of each week, right? So at least by the start of the following week, you're focused on the content of that week, right? So I think we will close the submission on a Sunday, and then you can then focus on the content for the following week.
Okay, thank you.
Sure, thanks.
Okay. So maybe it's the last question. Harrison, do you have an additional question?
Yes, thank you. Although this is not part of what you taught today, so I just want to ask, is there possibility, because it is said that the absence of evidence is the evidence of absence. So I want to know if it's possible for us to earn a certificate after the course.
Oh, I think this is a question. I hope you can answer this. This is beyond my
Yes.
ability.
Yes, of course. Yes, Harrison, you'll receive a certificate of completion at the end of the 10 weeks, provided that you submit a capstone project, right? So the project would then determine if you've learned the concepts that were taught within the period of 10 weeks, right? So getting through all the classes, assignments, as well as the capstone. So I think we'll just base the completion, you'll get your certificate of completion on the learning management platform once we have marked your capstone project, right? At the end of the 10 weeks.
Thank you very
And
much.
yes, the I think maybe let me say this because I think others also asked, but the certificate will also be free, right? So you don't have to pay for anything on the thing.
All right. Thank you, sir.
Perfect. Over to you, Prof.
Yeah, Favor, please.
Thank you so much for this opportunity. I would like to find out concerning the assignments, where exactly do we have to hand them over? Is it on GitHub, or is a specific place where we hand in our assignments?
Prof, can let me okay. So we have developed a learning management platform, right? Where we do all the testing, right? So this is where you'll find all your assignments, as well as getting your certificates, right? I'll drop the link in the chat, and just follow the link, and then it'll direct you to the learning management platform.
Okay, I think it's a time. Okay, thank you everyone here, and thank you very much for giving me such opportunity to introduce Python language, and thank you very much for all the colleagues in the Zoom meeting, and it's very nice to use your course well. It's very good. Okay, thank you very much.
Thank you so much, Prof. We really appreciate you. Thank you for your time, as well as the content that you just presented. We really appreciate you.